1, action. Video bomb. Okay, done. All right, so here we have Kingdom Animalia, phylum, I don't know, Chordata, subphylum, what's subphylum? Craniata. And infraphylum, how about vertebrata?
Oh,
Superclass,
vertebrata.
Superclass, do it.
Nathostomata.
And then class, chondriches. Oh, I hear the voice of knowledge behind me. It's pretty cool. So these are smooth time sharks. We have a male and a female. The male did not preserve properly. They're not supposed to make that sound. So we're not going to spend much time with him. We're just going to look at external anatomy, and then we'll focus on the female here. How do I know? He's a male? I read the bag. It said male on it. And I looked at the pelvic fins. So here's the girl's pelvic fins. And you can see there's just a couple of fins there. And if you look over here at this one, these pelvic fins have special extra things on them because he's a boy. So those are his boy parts. In fact, that's analogous to the penis. And he has 2 because why not have 2? No, he's going to, when he fertilizes the female, not this one because she's dead. And he won't be doing any fertilizing. But if he did, he would want to fertilize both left and right sides because she can get pregnant on both sides. So he fertilizes all the eggs on the left and all the eggs on the right with his double structure there called a clasper. That's a clasper. And if we go, so that we have the pelvic fins then and pectoral fins. Pectoral fins, wow. And then we have a caudal fin here. And then we can see the vertebral column come up onto the dorsal lobe of the caudal fin. What kind of tail is that? Heterocircle is correct. One person said heterocircle, then everybody else said homocircle. For the record, Loy got it right. Here's a dorsal fin, and here's another dorsal fin. Now I'll tell you guys a little secret about dorsal fins. Shark dorsal fins turn water red. Because if you're out in the water and you're swimming and you see a dorsal fin, all of a sudden the water's red. Because it bit you. Here's the spiracles. It's a hole in the top of the head and allows water to get into the gill chamber, which would be here, when the shark's resting on the bottom. So she's resting on the bottom. She doesn't want to take in a mouthful of sand, so she brings water in from the top here. Normally she would bring water in through the mouth and into the gill chamber here. Now on the ventral side, we're looking at a couple of... What'd you find?
I was going to open it.
Don't get bit. So we have nostrils. Now, what do you do with your nostrils? Breathe. She does not breathe with her nostrils. She uses them just for smelling. But really, she smells really well. And if you look, if you're Erica and you get to see it, with the rest of you forget it. If you're Erica, you get to see it. I'm moistening the nose here, and you can see all these little pits. All these little pits, they look like freckles, but unlike ginger freckles, these have powers. In fact, in a sense, these structures are called ampullae of Lorenzini. And then, you didn't say it in Italian, I thought you were going to say it in Italian. They're sensitive to electrical currents. Anytime you move an object in a medium that has ions in it, then you create an electrical current. So when you're swimming in the ocean, you create an electrical current around yourself. Now this shark can feel that electrical current. Let's say there's a fish underneath this tray hiding, and the shark was alive and there's salt water around. Because we're assuming a lot here. And then if the shark swam over the top, it would actually be able to feel the presence of the other fish underneath because of the electrical field that other fish is creating. Pretty cool, right? They're freaking Jedi. And then here's lateral line. That's not a very good example. Let's look over here. See it? Oh, here we go. Lateral line right here. I'm mixing. All right. So let's look at the internal anatomy, and we'll go open this up.
Is this where I'm going to come in?
You're not as good as that other person.
What other person?
Who was it? Because she was awesome. Who was it? Oh, it's Colin.
Wait, why, what did she do different?
She was very good at anticipating. So here we have the liver. Huge liver, right? Whoa, more and more liver. All right. See, you're pretty good. More liver. It's lots of liver. It's all liver. And Erica, since you're touching this, can you kind of do this? How would you describe it? What are you feeling there?
Smooth.
Smooth, maybe a little slimy. How about greasy? Would you go greasy?
Yeah.
All right, greasy. They are greasy. But what you saw on the dissection of the perch, you saw swim bladder. Sharks don't have it. Instead, they retain oils in their body. So, what do you know about the density of oil compared to the density of water? Like on a bowl of soup, it's lighter, right? Because the oil comes to the top. So these guys retain some oils in their body, helps with their buoyancy, with their ability to float. And they're magical. And then here's the stomach, in Spanish, el estómago. There's the stomach. And then if we look inside the stomach, this is a pretty big stomach, right? And I thought, oh, it's going to be so cool. We're going to find some stuff. What did she eat? Nothing. It's empty. But we can see these wrinkles. See the wrinkles right there? Those are called rugae. They allow the stomach to stretch, allow this animal to eat much bigger animals than would be suggested by the size of the stomach, and the increased surface area for secretion of enzymes and absorption of nutrients. And she got some fat on her stomach, too. And then if we look down here, what's this membrane bugging me? It's the mesentery. Lots of mesentery. We got, as we approach down here to the stomach, there's a U-turn. And at the tip of the U-turn, there's the spleen. Does the same thing a human spleen does. And then it goes up this way, and then down that way. Now, before we make that last turn, that next turn, we find an organ in the mesentery. That's called the pancreas. There's a piece of pancreas here. And piece of pancreas here. You can see the kind of the peach tan. What color is that? I don't know. See that color right there? Represents another piece of the pancreas. And the final part of the digestive tract is normally the intestine. In this case, the intestine doesn't look very long. Now, we don't call it an intestine in the sharks. We call it the ileum. And it's kind of short. How long's your intestine? Oh, well, like 15 feet of small intestine, maybe at least. Well, how can it get away with only having maybe 8 inches of... Is it 8? Sure, 8 inches of small intestine. Well, it's 8 on the outside, much longer on the inside. I'm going to show you a structure called the spiral valve. The spiral valve. See the dividers in there? It forces the food to take kind of a circular route, a corkscrew route as it comes through. It doesn't just go straight through. Instead, it goes around and 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 around. You get the idea. So on the inside, like to travel the distance from here to outside, that might be 1.5 feet or 2 feet. Whereas on the outside, just going like this, it's 8 inches. So it greatly extends the length, the functional length of the ileum. And again, that's homologous to the intestine of other vertebrate animals. Here we have a gland right next to the rectum. It's called the rectal gland. It is for chemical communication. And what happens is Susie here will take a poop or a pee and she'll express that rectal gland. Her scent will go into the poop or pee, and then someone else comes by, another shark comes by and goes, oh, Susie was here earlier. I know, well, I couldn't remember her name. Was it? What was it?
Maggie.
Oh, it was Maggie before. Now it's Susie. She doesn't care. Okay, so that's good for abdominal, isn't it? Well, let's go find some reproductive organs. Now, Susie is an immature female shark. That means that she cannot sexually reproduce. And here's her ovaries right here. Flat, no eggs in it. That's an ovary. Really weird spot for an ovary, right? Right in the middle, super safe spot in the shark. Evolution says if you lose the ability to reproduce, then you might as well be dead. If this animal loses the ability to reproduce, it's probably dead anyway. Pretty cool, very well protected spot for the reproductive organs. Next, we're going to go into the pericardial cavity. Be careful because I screw up the transverse septum. Okay, so yeah, it's busted. So here's a membrane that goes across, separates. Yeah, there you go. Separates the abdominal cavity with the pericardial cavity. What's called the transverse septum. It's analogous to the diaphragm of other vertebrate animals, of mammals, but it's not muscular. It doesn't do the same thing. It just acts as a divider between the two areas. Now, we said that the strong muscular part of the heart is called the ventricle, and there it is. That's the ventricle. Emerging from the ventricle anteriorly is the conus arteriosus, and that conus arteriosus is headed to the ventral aorta and then to some gills. This cushy part right here is called the atrium. So again, we have conus arteriosus, ventricle, and atrium. If I flip that,
I'll hold this.
yeah, and then flip it. If I fold that forward, I can see a triangular structure right here. See the triangle structure right there? That's the sinus venosus. And the sinus venosus receives blood. The blood then goes from sinus venosus to atrium. From atrium, fold it down. From atrium to ventricle, and then ventricle to conus arteriosus. Easy money. Any questions about the shark dissection? And